Now we'll see next numerical. Calculate the conductivity of germanium sample if a donor impurity is added to extent of 1 part in 10 raised to 8 germanium atoms at a room temperature, and given atomic weight of germanium is 72.6, density of germanium is 5.32 gram per cc, Avogadro number is 6.022 into 10 raised to 23 per mole, mobility mu is equal to 3800 centimeter square per whole second. Now, if we see the numerical again, then it is calculate the conductivity of germanium sample if donor impurity is added to the extent of 1 part in 10 raised to 8 germanium atoms is given. So it is mentioned how much donors per total number of atoms are active. But in these numerical, total number of available uh, concentration of electrons is not mentioned. So first we have to find out how many total number of electrons are available for um, these process is to calculate, and then out of that available active electrons, only one electron per 10 raised to 8 germanium atoms, which is useful for the conductivity. So first we'll see what is given. The given is the expression for conductivity is given by, first we'll calculate what is the formula that will check what is the conductivity, which is sigma is equal to n into E into mu suffix E. N is the carrier concentration, is the charge, and mu suffix E the mobility of electron. So first we should know what is the value of n. For that purpose, we know the standard formula to find out number of germanium atoms. To find total number of germanium atoms, we use this Avogadro number, atomic weight, and density. So this formula is total number of germanium atoms is equal to Avogadro number divided atomic weight into density. Now Avogadro number is the standard constant, which is 6.022 into 10 raised to 23. Mostly we are taking here 6.023, but when it is given that number we should use. Then atomic weight of germanium, which is 72.6, and density is 5.32. So we'll put the value, and by calculating this we'll get total number of germanium atoms, which is 4.412 into 10 raised to 22. These are the total number of atoms per centimeter cube, or we are saying per cc. But this number we could not take directly, cause clearly it is mentioned 1 part in 10 raised to 8 germanium atoms is added as donor. So donor is, out of these total numbers, only 1 per 10 raised to 8 will be useful. So first we'll that calculate. There is one donor atom per 10 raised to 8 atoms of germanium atoms. Hence, the donor atoms will be N is 4.412 into 10 raised to 22, which is we have calculated, divided by 10 raised to 8. So we get total number of donor atoms will be 4.41 into 10 raised to 14 per centimeter cube. Now these number we should substitute to calculate conductivity. That conductivity formula is sigma is equal to n into E into mu E. Mu is given, n is calculated, and E is the standard constant, which is 1.6 into 10 raised to minus 19. So we'll put that values. N is 4.412 into 10 raised to 14. E is 1.6 into 10 raised to minus 19, and this this mobility is 3800. When you calculate, you will get the answer is sigma is equal to 0.268 mho per centimeter. This is the conductivity. In these numerical, n, calculation of n is more important, and if the total number of atoms is not given, then we should calculate by using the formula of Avogadro number upon atomic weight into density. That time it gives us total number of atoms. And then whenever they mention how much donors are there, a donors means how much atoms which are the actually responsible for that n type semiconductor or p type semiconductor. That much atoms we should consider. Okay, so we'll see in next numerical. Calculate the conductivity of pure silicon at room temperature when concentration of carrier is 1.6 into 10 raised to 10 per cc. Calculate the conductivity of pure silicon at room temperature when concentration of carriers is 1.6 into 10 raised to 10 per cc. Now here silicon is mentioned. There is not a mention it is p type or n type semiconductor. So general formula we should use, and in bracket there is given mu suffix e, there is mobility. Okay, so see the givens. Given is first given is mu suffix e, that is mobility of electron, which is 1500 centimeter square per whole second. Then mobility of hole which is 500 centimeter square per whole second, and carrier concentration which is given 1.6 into 10 raised to 10 per centimeter cube. These centimeter cube and cc both having same meaning. Now if you observe these numerical, then it is pure silicon is mentioned, that it indicates it is intrinsic type of semiconductor. That's why here we have written n suffix I. When intrinsic type of semiconductor, that time number of electrons and number of holes are same. So instead of writing n suffix e and n suffix h, commonly we are writing n suffix I as an intrinsic semiconductor, and that time both electrons and holes are in same number. Now the total conductivity of pure silicon is given by the formula sigma is equal to E n suffix I into, in a bracket, mu suffix E plus mu suffix H, where E is charge, n suffix I is carrier concentration of holes and electrons. That numbers will be same. And in bracket, carrier this mobility of electron plus mobility of hole. Just we'll put the values. So conductivity, by putting the value, E is 1.6 into 10 raised to minus 19. These value of n suffix I is given 1.6 into 10 raised to 10, and this value of mu suffix E and mu suffix H, which is 1500 and 500. Substitute these and calculate again by scientific calculator only. Most of the time I am saying you should use scientific calculator only. So see this, it will be answer is 5.126 into 10 raised to minus 6 mho per centimeter. This is about some numericals. Now you can solve other numericals which are given in different reference books or some textbooks. Okay, here we'll stop about these numericals. Thank you.